Hey, what's up, Ziguanas? This is day 6 of the 30 Days of Zig Coding Challenge. I invite you once again to join me as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new language. The name of the language is Zig. My name is Dusan. Welcome to Zignited. Yesterday I stopped with for loop because I encountered something that I didn't understand, and it was that pipe syntax. So I'll show the screen and what I mean. So this thing, because I've seen that with for they use this pipe, some variable name pipe, and I did not want to waste time and trying to find the answers online the live stream. So I went offline and I just researched a little bit. So first I asked Gemini to provide some initial explanation so that I understand what to search for. And I asked this question: what does this syntax here represent in the following Z code? And I just copy pasted from the language reference this code, and then the ChatGPT answered this here. So it started explaining, there is a loop header and so on. So it went into details, and this is the important thing, that it explained this part here, that it's a capture pattern for the loop. Then I looked up capturing, and I found this text on this website. I will zoom in a little bit so that you guys can see why this doesn't work. I'm missing the key, that's why it doesn't work. So this is the website here. So I found a question. So someone asked the question. The person said that they don't understand this concept here, and I will not go now through this entire explanation. I will just find the part that is related to the for loop here. And someone who answered explained it in this way: for loops only work on arrays, slices, and ranges. And of these three, I went through arrays only. So no slices, no ranges. I'm not familiar yet how they work in Zig. By the way, for the people that are here for the first time, the new ones, I just want to provide the context. So I have experience with about a dozen of programming languages, but I've never coded Zig before, like 6 days ago. So it was the first time I started streaming, and the idea is to document online the process of learning as someone who has a lot of experience in programming in general for 2 decades, and I also taught programming to many hundreds of students, different programming languages. So I just wanted to document how I would approach learning a new language. That's the point of this stream. That being said, I repeat, I've covered so far only arrays, not slices, not ranges. So I will see that today maybe I at least cover one or maybe both. We will see how much time I will need. And that's about these things here. So let's see the answer here. The payload is always the current iteration item. Okay, you can iterate over multiple objects simultaneously. And then they provide the re-examples. So this is array. This is looping through array. I remember this was the syntax. I guess this is a range or slice. I don't know. And this part looks like maybe something like destructuring or something like that. I don't know yet. So let's go back to the code and let's test things out. So this is the for loop part of the official Ziglang documentation, ziglang.org. That's where we stopped. And let's try to test these things. So, okay, I can try this part here. I will adapt it as before because I still haven't covered the error handling, so I will not use try expect if it's possible. Do I believe it should be possible just to iterate without error handling? And I will not do this part slice. I will step back and see how slices work. And the index of iteration. I think this is also a slice. So maybe I will just do the first example and then I will go back go one step back and research the slices and how they work before I continue here. Okay, so let's go back to, I'm using the site zig-play.dev to run Zig online so that I don't spend any time installing anything because I just want to go as quickly as possible through the language itself. This is something that I did last time, so I can delete most of these things. Don't need them anymore. And let's just do these few lines there. Okay, we have an array of i32s. It can be even simpler. Let's say i8 because they're small numbers. Then we have one variable, the sum. And then let's do this part. And I will adapt it a little bit. So for items, so I guess this is just to say that we are going to iterate over this items array. Value is the variable that we define here, so it's not defined anywhere before. We have only one constant and one variable. So this is similar with some other languages that you can, like on the fly, you can define a variable here. I guess by default this is a variable because it will change. It will take from the explanation that I've just read. This will take elements one by one, so it has to be a variable, so it cannot be const. But you don't have to explicitly say var, or probably you cannot. If I will try later. So probably it will break the code if I try and say here var. We'll see that next. But let's see first. Break and continue. Okay, we don't care about these. This is just to say that continue is supported. I've done continue yesterday. Know how it works. And this is just to increase the sum. And let's try to print it here. The sum. So let's say sum equals to, it's going to be a number, so I don't need s. Then let's interpolate here the sum. Okay. Run this, see how it works. Yep, sum 16. I will trust it. 9, 12, 16. Yeah, 16. Works as expected. So let's do try this var here. I guess it's going to break just to see. Actually allowed. Yeah, it's not allowed. Yeah, you have to use the identifier directly. So it's just like a short syntax, and that's what they support here. So like I said, I'm not going to try these. I just want to see one of these examples. Maybe it was in the other. Yeah, it was not here. They do here. Aha, they are looping through multiple arrays. Okay, this one I can try because it doesn't use the syntax, which is either slice or a range. I don't know yet. So what is different? Is different this one and this one? Ah, they use pointers. Okay, I will also, because I haven't touched pointers, I did use them in one of the first videos that I streamed, but I just played with I hacked them a little bit, so I just wanted to see how they work without actually going deeper. So that's why I'm going to skip over this example as well for now. And these are optionals again. I haven't touched yet, so let's do just this one from here, and then I will go back to that other site where I found the answer how this works. Try and do this. I think it was deconstructing. So I will just see that is what I think it is. And let's comment out these for now. See what we have. Oh, I comment out many things. So here is the new thing. Okay, items 2. They are with unspecified size. I think we had, yeah, the same thing here. It's use size. This doesn't matter the type. In this case, count use size. So we create a count, which is equal to 0. And then we loop through both of the arrays in the same time. We create these I and j variables here. And then we increase the count by the sum of the I and j. Okay, and let's just print paste from here. And in this case, it's a sum. It's a count, not a sum. Okay, 21. So I guess this is 1, 4. It's 5 plus 7, so 12 plus 9, yeah, 21. So it does what it looks like. Okay, let's just try to play. Let's see if I have one larger sized array. Probably gonna break just to test. Yeah, are matching for loop lengths. Okay, so we know they have to be the same size. And I guess I can do the third one. Let's just quickly check. Maybe actually that was what was on the second page. So this doesn't matter. I just want to add a here. We have to say that we want to go through items 3 as well. And then let's use, I think we cannot just, like before with variables, if we don't use them, it complains. So I'll try not to use k in the next run, but let's first run in this way. Yeah, this works. So we had 21, and this is 4 and 5, 9, 6, 15. So yeah, 21 and 15 are 36. Okay, 36. So let's now try not to use the k. I think this is going to break. Double check. Yeah, unuse capture. Okay. Aha, now they say it's a capture. So literally now makes more sense. And here, when we were reading through this payload capturing, so it's a capture definitely information. And I wanted to, aha, yeah, this is what I thought it was a destruction. So it's not deconstructing anything. It's just, it's not destructuring anything. It's just going through 3 arrays in the same time and just like capturing 3 values in parallel. Okay, I mean not in parallel really, but let's say parallel. Okay, so back to the code and to the documentation. So nothing else here I can use before actually. I mean, I can probably understand what it will do, but I don't want to skip over. If I'm going to use slices or ranges, whatever these are, I want to see how they work. So let's see here, slices. Slice is a pointer and the length. So together, the difference between an array and a slice is that the array's length is part of the type and known at compile time, whereas the slice length is known at runtime. Aha. Both can be accessed with the length field. Because len obviously will work in the runtime and in the at compile time, same time. Okay. So because they're pointer, I want to go through pointers as well. Let's just see if I look for range, say here, and this is where they speak about the switch. I just want to see the order here. Where is the switch in the it's here. So it's after the slices. So let's do then, instead of ranges, let's do slices, but before the slices, let's start with pointers. Let's see what they do and how they look like in Zig. Okay, Zig has two kinds of pointers, single item and many item. Okay, the one with the star, and that's a single item, and square bracket star, it's many item pointer. So this one is pointer to exactly one item. This one is pointer to unknown number of items. So it doesn't have to be specified what is the number of items, which means then it will work, should work with arrays. They're dynamic. Okay, let's start with these. Supports dereferencing syntax, pointer, star, pointer, supports slice syntax. So this was a slice, the thing that we've seen down there. Yeah, so every time you learn a language, the things are intertwined. So it's impossible just to cover one topic that is not related at all to other topics. So you have to start somewhere. And I just decided to start with pointers because instead of slices, because I believe pointers are more, let's say, basic thing than slices. Supports pointer subtraction. Pointer minus pointer. You have pointer arithmetics. That's interesting. Then the many item pointer supports index syntax, pointer, and then the index inside. Well, that means that every time you access array with an index, you're actually having a pointer. Okay. Supports slice syntax. So you have start and then like here. And pointer start. So they're different because here you don't have this open-ended slice. I guess this is like in some other programming language that means you go until the end. Maybe I'm wrong, we'll see. But looks like this is from this starting point that you defined until the end. Supports pointer integer arithmetic, so addition and subtraction. Here it's only subtraction. That's interesting. And here it's only, here it's both addition and subtraction. Supports, it's different. This is pointer subtraction, which is the same like here, so only subtraction. But pointer integer arithmetic is supporting both addition and subtraction. Okay. T must have a known size. It must have a known size. Does this apply? So this is not under the point here, which means it applies to both single item and many item pointers. Must have a known size, which means that it cannot be any opaque. So I still haven't touched these. I just remember them from the first day that I read something about them, but haven't used them yet. Or any other opaque type. Okay, we will come back to them later. Let's see what else they say about. pointers. These types are closely related to arrays and slices. Yes. See what they have here. What is different? So they have a star in front of. So here the star is inside of the square brackets, and here it's in front of them. And in this example, there is nothing. They're empty square brackets. So let's see here. So there is another type. No, this is the n, the number. Okay. So pointer to n items. Same as single pointer to an array. Yeah, so they have 4 kinds of these. Supports index syntax, like here. Supports slice syntax, like this one. So only this part and not this part here. Supports len property. Okay, so because this time the length is known, that's why you can use this one. Makes sense. Supports point. I will probably confuse all these at the beginning. But let's see. Supports pointer subtraction. Again, they all do so far. And then let's see the empty square brackets t is a slice, a fat pointer, which contains a pointer of type this and a length. So basically it builds on top of this one. Supports index syntax, slice index, supports slice syntax, slice start end, and slice length. Okay. Use %x to obtain a single item pointer. Let's see what they do with them. So this was out of theory, but I guess it was necessary to go through all these. Let's now see in practice. Okay, I will not play with pointers. Get the address of a variable. Let's do this for now. And comment out these. And let's print. So let's do both. Actually, I can just print the pointer because I use. Let's see if this is going to be enough. Because remember, if I don't use a constant, it will complain. But I think because we use it here, this is basically a different thing. So I'm using it as a reference. Let's see if this is going to pass. So I will try just to use the x pointer variable. Let's see. Okay, this worked. So it's an i32 type at this memory location. So this is of course hex. We don't actually care about the address itself. And this is of course going to change in runtime. Every time I run it, it will be different address. Okay. So pretty straightforward. And here, if we compare it to this, we haven't used explicitly star to dereference. This is what we used, but I guess the type, if I run it, will be this one. Let's test that. Let's do here the type of xtr is, and then let's do type of, and then xptr. And I forgot if I have to say any here. Let's see. Run the output of type of. Yeah, it works without any. Okay, perfect. And like I thought, it is a pointer to the type, and in this case, the type is the i32 constant. So it's the first case. Okay. This part makes sense. let's see their next example. Reference a pointer. It's interesting that they use the dot notation. So I've seen it somewhere here. And I actually thought they just like made a mistake, like a typo, or that they finished the sentence. I didn't pay attention. I kind of like went quickly through these parts and I thought this is something like that, but actually it's a syntax. You have to use a dot notation. This is very weird for me because I've never seen such notation before. At least I don't remember. Okay, let's see what they do here. They say, they're just like comparing. I thought it was equal sign. I thought they were assigning, but it's a comparison. So this is just going to say true if it matches the value. In this case, it does match. And then they try these. They ask if the type of the pointer is what we saw it is. So this is also going to be true. But let's see what they assign here. I don't see them assigning it. So what, here they do assign. So they have the assignment with equality operator. So I guess it will also work if I just straightforwardly assign. And here they use the same verb. Okay, so let's try to print this first, just to see the thing. And before I print, let me go to the next line here. So here I'm going to do, so let's just paste what we have, then do here this part. So I want to see if the pointer has the value of 1, 2, 3, 4. So we expect to see true if it does, and we expect to see true. What does it say? It's an unused argument. Which one? Pointer. Which line? Ooh. This is somewhere deeper. 24. What is this? So what is happening? I understand. So, okay, my mistake. I forgot to say this, of course. So let's rerun. Okay, yeah, it's true, like expected. And let's do the same thing for the next one. The next example they have, this one. So we expect also this to be true. To their example. Okay. So let's do one more time. Now I actually want to do, so this is a constant, I cannot change it, but I can make it a variable. And by the way, before I do that, I think this is going to now break because I actually never change it. And it's a variable. So let's try and see if it will break. Yeah, never used. So I have to change it, and that's a perfect opportunity to actually try to do what I wanted. So dot star equals, and then let's say 1, 2, 3 instead. And now what I expect to see is that, of course, this is here printed out the value, the new value. Then the type shouldn't be the pointer to the constant I32. It should be the pointer to a variable I32. Then this should be false, and this should be false. See? What did it say? Never mutated. How come? Which one? Ah, X pointer. Oh, I made a mistake. I didn't want to make this a constant. I wanted to do this one. But wait, I mutated the wrong one. What happened here? What did they do? So, yeah, this is the one that I wanted to try to mutate. So not the X pointer, but like this. Can I do this? I wanted to try this actually. So the var X is I32, and then I try to change it here. Let's see if this will work. Aha, you cannot do that. Okay, you cannot dereference non-pointer type I32. Okay, so then it's the same thing. So I can leave this one as, maybe they're related because I'm making a constant. So it's interesting to see what will actually happen. So let me first simplify. Let me just use 1. We can actually do this in a different way. So comment out these and make a new version where I will play. This one doesn't work. I will delete it, and then I will leave this out. And here, let's first of all simplify. So I want this to be variable. Let's actually delete this one. So I want this one to be variable, and it's going to be a pointer. So let's actually keep both of them, but I will make both of them variable. I32, and this is the variable pointer, this one. Then I want to change, just for this not to complain, I will change the value of X first to 1, 3 instead of this, and I will not touch the others. I just want to see how this works when I change the type into the variable and then run. So one step at a time. And what did I say? Never mutated. Which one? Pointer itself. Okay, so now let's try, because it's a pointer, let's try X ETR dot star equals 100. Let's see if this is going to work. Okay, so then it's about the address. So I literally have to change it to another variable. So if I had, for example, y here, let's do that. So let's say var y, it doesn't matter what it is. Let's do the same type. I mean, probably it does matter because the type, let's see. I will first try with the same type. And then here I will say, instead of the dot star, I'll try to rewire the, so probably a bad idea to call it an X pointer now. Let's call it a pointer. And then of course here I have to change. Has to be, I mean, this is just for cosmetics, but be precise. And this is where I actually have to change. So a. Yeah, I hope I haven't missed one. So now again, I have two variables. Probably this is going to complain if I don't change. So y I have to change as well. So let's change y into 100 just for this compiler to be happy. And then I want to do this here. So mutate not the content where the pointer is pointing to, but the actual pointer to point to y. And let's run now. Yeah. So it's a different address. The type is pointer to the i32. So they don't say var, they just say i32. So pointer to a constant and a variable, they display in a little bit different way here. And then the content is false because I changed it. And the type here is not const i32 anymore, it's the i32. So I guess if I do this, now this is going to be true. And because I changed it to match the y, and I changed the y here to 100, it should be 100. Let's see now if we're going to get true and true. Yeah, okay, that makes sense. And now what I can try is what I actually wanted to try before. So not to change the reference of a pointer, but I mean not to change the pointer itself, that it refers to another memory address, but to actually use this dot notation and a star to change the value there. So we have 100. So let's try to change that into 200, for example. So if this doesn't break, I just expect here to change into a false. Let's run. Should be still the same i32 pointer type. Yeah, it's false. And let's actually print out y as well, just to see the value. Let's do it here. Actually, let's do it first here. So y, and then let's say equals, and then just let's inject here, instead of all these, just y, and run the code. So it should be 100, 200, not 100. I change it, yeah, 200. Okay, all these make sense. Now what I wanted to see if I can change the pointer to point to a different. I guess not, because this is the type. So the type of this pointer is this one, but I want to see if there is something like shadowing or something. Let's try and do that. So probably if I can shadow, I have to use var in front again. But let's try first the thing that I think is going to break. So let's try first to do this as a different type. So let's do this as i16, for example. And I guess this is going to break because I cannot assign a pointer that points to i32. Yeah, this doesn't work, but can I do... So this is now problematic, but can I do this? Can I redefine it? Shadow it? I cannot. Redeclaration. Okay, so this does not work. Write in the comments, you guys, if you know where this works, in which programming language. Okay, so I have one in mind. Let's see if I can do something. So this will not allow me to change the pointer type to an i30 from i32 to i16. So then basically I cannot do this. Okay, I'm not play with casting. Probably also it will not allow me to do that. Those are that I don't expect to work. So let's put this back. Actually, I can leave it, doesn't matter. It's not a working prototype. It's the one that doesn't work. Let's see the next thing here, what they do. Okay, here, there is a variable, there is a pointer to it. They just test if the type is a pointer. This is literally what I did. I'm gonna change to a variable. And they just did plus equal 1 instead of reassigning. They just like took the previous value and added 1. So I'm not going to play because it's very similar to what I did. Let's see here what is next. Taking an address of an individual element gives a single item pointer. So that's the first type. Okay. This kind of pointer does not support pointer arithmetic. So it does not pointer integer arithmetic. It doesn't support this one. It just supports subtraction. So probably they meant pointer integer arithmetic. So let's see what they do. They create an array. Why they quote single? Because they point only on a single item here. So yes, because you are using the index here, and with index you're targeting the number 3 here, and that's an integer. That's why this pointer is a pointer to U8, because it's array of U8s. And it's still a single item pointer because it points to only one of them. And what they said here before, variable. Okay, so I mean, they guess if you want to mutate with the pointer. Okay, let's do this part. And I'm not going to print. Actually, I can. So let's do this. Okay, we have a variable, we have a constant. We then can print here instead of this try. And what I'm going to print, I can say type of is matter. Then let's do a dot and curly braces here. And because this is a variable array, probably complain because I don't use it, but see, because I don't change it. Oh, actually it does not. So I forgot that when I did the like arrays 2 days ago, or yesterday, I already forgot. It's not going to complain. So it doesn't complain if the array is variable and you don't change it, just like if you do the variable on a specific value. Okay, so the type is, yeah, this is not a type because I have equal here, but I just want to do this actually so that I get the type as pointer to an unsigned integer size 8. It's, yeah. Okay, this makes sense. Then what's the next thing? They try, so they say this doesn't work, so would break the code. And this pointer, so the constant here refers to an address, not to the content, right? So this actually should mutate the value, not, let's see. So if I do this, and then if we just print the pointer's value again, so let's say char star equals, and then let's do char star here. Yeah, so this is okay. and I probably should have done this so that two lines. Okay, so this makes sense because what you get here is a pointer to an unsigned integer of size 8 bits. And if you use that pointer with a dot star notation, you're actually asking to access that memory location and take the value there, which is in this case 3, because index 2, right? 0, 1, 2. So this one. And then you increase it by 1, and then 4. You get 4 and assign it, because of the equal part, to there. That, well, that array. Basically, it goes back to an array, that location. So we change the array. And then we get 4, because this pointer still points to the same memory location, still points to this element. It's just like a different value there. So we are not changing pointer itself. So the address is constant, so it's still the same address memory, but on that address we have a different value. And let's just to make it more clear, let's just print the array itself in the next line. So array is called array. So let's say array equals 2, and then let's print an array, and I believe this is n here now. Yeah, now we have this, what I've said. So change that piece of an array. Okay, all makes sense. And the last example, okay, this is pointer arithmetic. So I will probably do just one more example because I'm already streaming on almost like 1 hour. So I will just finish this one, and then maybe tomorrow I will move on to pointer arithmetic. Okay, let's see this one. What does it say? Okay, we define x, we make a pointer to point to x. Then what we do here, we slice it. Okay, I will just do this as an introduction to slices as well. So I will not go deeper now and explain. I mean, not explain because I don't know how they work. I wanted to say I will not go deeper and see how slices work. So maybe tomorrow I will come back to this example and go deeper. But for now, I just want to quickly run it and see the output as the last thing for today. Let's comment out these. And let's do this part here. Create an array slice, and then instead of this, I will actually print it. So this is one thing before the last one. I've seen that there's some other line down there. So let's say here, x array r equals to, and then let's do this here, and let's do \n before I forget. What did it say? What did I do wrong? Expect semicolon where statement here. What did I do? Type of x array, and a dot. I missed a dot. Yeah, sometimes these compiler errors are misleading. So fortunately, I already have a few days of experience in Zig, so I remember the dot. But this is not helpful at all. Yeah, it's pointer of y1. Aha, because the slice here it says go from 0. So I guess it's in like in most of programming languages that this is like the included part. So it does take the first value and then it goes up to this index, but it doesn't include this one. That's why 1 is the size. So it's a pointer to basically it's a slice, but it looks like an array of size 1 that is the array of integers 32-bit size. So let's just like double check the theory that I've just prioritized. So I want to see what this contains. So because it's a pointer, I want the dot star notation. And then here I want to see what it actually is instead of these, the value, because I believe it's the first. Wait, what we are having here, it's a pointer to x, and this is not an array, this is a variable, i32. Then we create pointer, then we do a slice of not an array, so this is not an array, this is a single value. Oh, this is weird. So is it possible that you can just like reach into the memory and take the larger slice? I don't think this will work, but just let's say if I print this, so I expect to see this number, right? So let's see first, not that part, this part. I want to say this part here. So yeah, I completely didn't see when I copy pasted that it's not an array, it's a variable or integer, not array without specifier or any. Okay, my mistake. So this is it creates array. Okay, this is interesting. So let's do n here. Now weird. Oh, it's been a while since I've done these low level things. It's so weird. What was the error? It says like not array. So it works now. It is 1, 2, 3, 4. Let's see. What was the error? I was curious. I am curious. Cannot form an array. So it does see it as an array without a specifier. Okay, so it looks like this kind of converts the type. Yeah, I've seen that because when we print the type, it's not integer, not s. My mistake. I wanted to say any. When we print it here, the type looks like an array, what I said. And the original type here is an integer. So a single integer with this value and this size, like 32 bits. And we make a pointer to it. And then we slice it here. And we use the pointer to make a slice. And then this slice is actually an array. That's what we have. So we basically converted this integer, which is a simple number, into an array which has one element. So I guess this is going to break the code. You shouldn't be allowed to go to a piece of memory that you haven't defined. Let's see what they say. Slice of a single item pointer must have bounds 0, 0, 0, 1 or 1, 1. Slice of a single item pointer. So it's still a single item pointer because we, okay, this is the restriction. So that's why. Got it. So it's the first kind. This thing here. Okay, now it makes sense one more time. But it's very interesting. And I wanted to just test one more line of code. And actually, before, yeah, I don't have to play. So I wanted to do actually now the second thing as well to see if it's inclusive or not. I kind of have my answer already, but I just wanted to double check if I do the slice of an array instead of doing this thing here. But like I said, it's better to leave it for the next time because already streaming for an hour almost. So let's just like check the last thing they do here. Coerce too many item pointer. Aha, this is the conversion or coercion, if you will. Let's see what they do on stacks. So actually, let's copy paste there. I will see here what they do. And this part I will comment out. So we have the second kind of pointer with star side. So this one here, right? Star inside the square brackets and the type after. So in this case, star inside of square brackets and the type I32 afterwards. Sorry, so it depends on this one. So I guess I will have to uncomment these. So this one here is used here, and it depends on this one, because I literally say equals to this one and something afterwards. Then this one depends on next. So yeah, I have to use all three. So let's see. Then the next step is here to create this, to actually coerce it a different type. This type, that is how they officially call it. Many item pointer. I was about to say multi-item. So many item pointer from a single item pointer that we have. So this one is a single item, and we want to create a multi. And it's just as easy as this one, as this line. Okay. So let's just print it here. So instead of try, I will print here, and I will, yeah, let's do it here first. So let's say x many ETR is going to be equal. Let's see how this will work. And then dot braces here, we end here. And let's do this one first. And then I would like to also, let's actually do this first. Yeah, it's 1, 2, 3, 4. And I'm kind of like trying to not to think about doing this with this multi pointer and trying to expand the slice to more than one element, but I'm not going to do that today. So I'm going to do that tomorrow. This is enough. And just as the last thing, let's print the type of. So let's say the type of, and then this thing here. And then let's do the type of here. Right, so not this one. Yeah, this one. X-Men pointer. Yeah, that's the one. Okay. So it should be this one. Yeah. So I was about to say it should be this one. Exactly. I just wanted to double check how it looks like. Actually, it's the output. Okay. Makes sense. So looks like we covered this part here. This part, I didn't do anything with this. And still, there is this arithmetic part that I haven't touched. What is later? Slice bounds, comp time pointers, pointer conversion. Oh, there is a lot of things. They're about pointers, pointer conversion, comp time, pointer casting. Oh, so many things. Okay, so I will try to finish these pointer parts tomorrow. If I don't switch to slices or something else, I will think about it. Okay. That would be everything that I was about to say I planned for today, but I haven't planned because I haven't seen all these things before, so I did it live. But let's say that would be everything for today. Thanks everyone for watching. See you tomorrow. Bye bye.